simplifying expressions with rational exponents. For the first example, quantity 3x raised to 1/3 squared times 3x raised to 1/2. So first, we're going to apply power of a product here, where we distribute squared to each base equals 3 has an exponent 1. So 1 times 2 will give us 3 squared. Then x raised to 1/3 times 2. Next, 3x raised to 1/2 equals, now 3 squared is equal to 9. X 1/3 times 2. Of course, when multiplying fractions, you multiply numerator by the whole number, which will give you 2/3 times 3x raised to 1/2 equals, now we multiply each coefficient. 9 times 3 is 27. Then we have here similar base, which is x. Now we have here similar base, which is x. Copy x and then add their exponents. 2/3 as 1/2. In this case, the denominator are different. So these are the similar fractions. We need to make them similar by getting first the LCD. And 3 and 2 has an LCD which is 6. And then 6 divided by 3 times 2 will give you 4. Plus 6 divided by 2 times 1, 3. Then we simplify this one, which will give us 27x raised to 7 over 6. 7 over 6. Next, number 2. Quantity x times y raised to 3/4 times z cubed raised to 1 over 12. We're going to apply power of a product equals distribute 1 over 12 to each base. X, since x has an exponent 1, so 1 times 1 over 12 will give you 1 over 12. Then followed by y, exponent is 3/4 times 1 over 12 times z cubed times 1 over 12. Then we simplify. X raised to 1 over 12. For y, 3 times 1 is 3 over 4 times 12 is 48. Then z, 3 times 1 is 3 over 12. Now we simplify. Equals x raised to 1 over 12. Then y, simplify 3 over 48, that is 1 over 16. And then for z, we have 3 over 12, which is 1/4. Number 3, quantity 2x raised to 1/2, y raised to 2/3 all over 2 raised to 1/2 x raised to 1 over 6 y raised to 1 over 6. In this problem, there are two ways to solve this. You can use power of a quotient or you can use quotient of a power. In this case, I'll use quotient of a power first. Equals. So I'm going to solve first for the inside of the parenthesis. So I have here similar base 2, similar x, and y. So 2, which has an exponent 1, so I'll write 1, minus the exponent in the denominator, 1/2. Then I have here x with exponent 1/2 minus the exponent of the same base on the denominator. And then y, again, the exponent in the numerator, 2/3, minus the exponent in the denominator. Okay? We have here 1 that is invisible. Then raised to 1 over 6. Now, let's solve first for these fractions. 2. 1 minus 1/2, of course that is 1/2. For x, we have here, they have different denominators, so these are dissimilar fractions. We need to get the LCD. And the LCD here between 2 and 6 is 6. 6 divided by 2 times 1, 3. Then we have here minus sign. 6 divided by 6 times 1, that is 1. Let's go for y. So also, we need to get the LCD here. So 2/3. LCD is 3. 3 divided by 3 times 2, minus 3. Raised to 1 over 6. Then simplifying this one, so give us 2 raised to 1/2. Then x, 3 minus 1, that is 2 over 6. And then y, 2 minus 3, negative 1 over 3, raised to 1 over 6. Then of course, this 2 over 6 can be simplified to 1/3. Now, we use power of a product here. We distribute 1 over 6 to each exponent, which will give us 2 raised to 1 over 12 x. 1 times 1 is 1. 3 times 6 is 18. For y, we have here negative 1 times 1, negative 1. 3 times 6, 18. Now, we have here a negative exponent, so meaning y raised to 1 over 18 will be put in the denominator. Our answer becomes, so our answer here becomes 2 raised to 1 over 12 x raised to 1 over 18 all over y raised to 1 over 18. This is our answer for number 3.